Any questions on any of the homework so far before we delve into the last section? So what we're looking at lastly is inverses. So what we're looking at last is inverse functions. Now, the inverse of a function is also a function if and only if no horizontal line intersects the graph of f more than once. So we are used to the vertical line test, because if you can draw a vertical line on the graph and it only crosses the function at one point at all spots, then it is a function. Now, the horizontal line test is checking for inverse, because whenever we inverse a function, and y'all have done this in Algebra 1, our first kind of main step was to switch x and y, because we're going to flip the x and y to be able to find its inverse. Well, a vertical line, any vertical line, is really in the form of kind of y equals, not y equals, x equals a value, because x equals is our straight up and down. And that would be kind of the vertical line test, because that's all we're doing, drawing a straight line up and down, x equals, and going across. But if we switch x and y for its inverse, well, the x is going to become y equals a. We don't have an x also, it's just y equals a, which would be our vertical line, yes? So if we're switching it here, that means also for the function itself would switch. So if the beginning function doesn't pass the vertical line test, or horizontal line test, sorry, horizontal line, if we can't draw a horizontal line like this here where it only crosses once, or apparently that circle, like this here, then it doesn't have an inverse. It will not have an inverse in the current form that it's in. So here, the second one is the equation y equals x squared. Well, we can see right here it doesn't have an inverse, because we can draw a straight line and it crosses it at 2 points, yes? Technically, we can give it an inverse, because what we just say is that x is greater than or equal to 0. We cut the second half off, so essentially this entire part of the equation off, and just look at the positive side. Or we can do vice versa and just look at the negative, because if we just look at half that graph, then it does have an inverse, because it's only crossing once. So we have to do some tricks to get some of these kind of quadratics to work, or some functions to work. The same thing is true for sine, because if we remember the sine and cosine functions, they're essentially a wave. Well, that wave function would never pass the horizontal line test, because that's going to cross infinitely number of times. So we do have to have some restrictions when we look at inverses. Now, we're going to do this first problem this way, the way the kind of the book wants it. I find it weird. Ms. Kendall finds it weird that they do it this way, because what we're going to do is solve y, which is f of x, for x. So what that means for us is when we look at this first equation, the calligraphy pen, here, let f of x equal to x plus 3. So we're really saying that y is equal to 2x plus 3. So the first main step is we replaced f of x for y. I'm going to write this straight below that. I would, if I were y'all, I'd write it a little bit off to the side, because we're still going to need to solve or input that for 7. So, yep. So if y'all want to put it above example problem below the core concept, that would work too. Okay. Now, after this one, our next kind of main step would be to switch x and y, because that's what we're doing. When we find the inverse, we're really switching the x and y values, the domain and range. But for this one here, we're just going to try to get x by itself. I'm wanting to solve for x. Y equals 2x plus 3. What is the first thing we can do to get the variable x by itself? Subtract 3. And if I subtract 3 from both sides, on the left-hand side, we'd have y minus 3 is equal to now what would we do next? Divide both sides by 2, which tells us that x is equal to y minus 3 over 2. Okay, so we solved it for x. Now the other part is to find the input when the output is -7. And when we talk about input and output, input is always x, output is always y. So here, we're saying -7 is going to be inputted for in place of x or y. Or y. We're saying x is equal to -7 minus 3 over 2. And we want to solve. Scroll down. Well, -7 minus 3 is negative 10 over 2, so x is negative. So there's one of our answers. And here's the other one. And that's all we have to do for this here. Any questions on any of this here? Now, I'm going to go on and finish these steps out so that we have them down. Now, for the rest of these here, we're going to replace f of x with y. The second one, we're going to switch x and y. We're going to switch the x and y values, because when we talk about the inverse of a function, we're really switching the domain and range. And I'll do a picture of what we're talking about here in a second. And then we want to solve the equation, solve for y, because we want to get y back by itself. And step number 4, replace y with f inverse of x. Any questions on this here? Okay. Now, as I said, I'll do a picture of this here. Is our domain, our x values, range, the y values. And a normal function, our function, we can call it f of x, is a function that maps, or as we say in kind of mathematics, maps a point in the domain to a point on the range. So when we take a value of x and plug it into the function, we will get a value in the range. That would just be f of x. What the inverse does is it takes that same range value and takes it back, maps it back to the domain. So we're switching the domain and range, because the function would take us from the domain to the range, and its inverse is taking it from the range back to the domain. And this is what we call f inverse of x. So for the inverse, we're really switching the values of x and y. That's why we flip it. It's really a shortcut to do that, to flip the x and y. It makes it a little bit easier to understand, but that's what we're doing, is we're taking it back to the original value. Now, for the rest of these first few here, I'm not going to deal with, or we're not going to think about Well, we're just going to solve for y, or replace f of x with y and solve for x. Let's just go on and find the inverse. So if we're looking at this here, let f of x be 3x minus 5. The first thing we need to do is what? Replace f of x with y. Then our second step is to switch x and y, which will give us x is equal to 3y minus 5. And I like doing this here. For these here, it's not that big of a deal to kind of work these here. But when we start dealing with radicals and squares, it can sometimes get a little confusing what we're trying to get by itself, what are we trying to group. And exactly, now at this point here, we would solve for y, get y by itself. We would add 5 to both sides. And what this would tell us is that x plus 5 is equal to 3y. Now what do? Divide by 3. Okay. Now if we divide by 3, well, 3y divided by 3 will simplify nicely to y. Well, x plus 5 divide by 3 nicely. Now, I would divide it by 3 if we had, say, 3x plus 6. Is 3x and 6 both divide evenly, then we can simplify it. Here, we can just leave it as x plus 5 over 3. So the last step is to kind of denoting that it is an inverse. Is our f negative 1 parentheses x close parentheses, because this here is just saying it's f inverse. This is the inverse function. And it is x plus 5 over 3. So this here is our inverse. Now I'll scroll back down here in a second. So this is our function, yes? Now the next part it asks is to find the input when the output is what? Negative 11. So graphically, kind of as we were looking at the last one, our input and output, we're saying that f of x took some value of x that we plugged into the function and gives us negative 11 out, yes? So the inverse function is going to take negative 11 and bring us back to that value. And that's all we're finding. What it's asking for, the output value is negative 11. What's the input for our general function? But for the inverse, we can just plug that negative 11 in for x, because this is our f inverse of x. So here we're finding f inverse of negative 11, which would be our negative 11 plus 5 over 3. Yes, negative 6 over 3. So f inverse of negative 11 is negative 2. And that's all we have to do for this here. Any questions over anything we've done so far? Now, if we looked at the original function, 3x minus 5, yes? Oh, I'm going to say 3 times negative 2 minus 5, because that's the solution we got, the input. This value over here was negative 2, yes? Well, 3 times negative 2 is? So the inverse is just taking us back where we came from. Any questions on this here? y equals f of x, solve y equals f of x or x, then find the inputs when the output is 2. Well, we just need to find the inverse. So the first thing we can do is well, yes, because if we see if switching it works, if we understand fully that y and f of x are the same thing, we could jump straight to x is equal to y minus 2. That's perfectly fine. Because if we're going step by step, we replace f of x with y. Our second step is to switch x and y. Now we need to solve for y. We need to get y by itself. Well, luckily for us here, we just need to add 2 to both sides, which tells us that y is equal to x plus 2. Or if we want to be mathematically, use the correct mathematical notation, we would say f inverse of x is equal to x plus 2. And that right there would be our inverse. Now we just need to find the input when the output's 2. So we'd say f inverse of 2 is equal to 2 plus 2. So f inverse of 2 plus 2, well, 2 plus 2 is 4. So f inverse of 2 is 4. That's it. Questions on any of this here? Questions on anything we've done so far? You feel good with these here? And I mean, we've done inverses before. Y'all done them in Algebra 1. Really, anytime we're solving, we use inverses because it's the opposite function. Okay, now we're looking at more Algebra 2 type inverses with these here. Now, our first main step for finding the inverse for this one here is we're saying what? Y is equal to 2x squared. Now, the next step was to switch x and y. So x is equal to 2y squared, because we're just switching the variables. We're not changing anything else when we flip them. Now, what do we need to do next? Yes. I would divide by 2 first. Because whenever we're trying to get a variable by itself, really addition, subtraction, if we have that option to use it, then we would look at multiplication and radicals or exponents last. Simplifying those last if we can. So here, we're going to divide both sides by 2. So our y squared is equal to exactly x over 2. Now we would square root both sides because we need y by itself and y squared. The only way to simplify that square is by taking the square root of both sides. Now what that'll tell us is y is equal to plus or minus, because anytime we take the square root of both sides, we have to add that plus or minus. Square root of x over 2. Now at this point here, we can rationalize the denominator because technically we do have a square root in the bottom of a fraction. But for us here, we'll leave it as this, because if we wanted to rationalize the denominator, we could, and it would just give us the square root of 2x over 2. Because we'd have to multiply the top and bottom by the square root of 2, which will make the denominator square root of 2 times 2, or square root of 4, which is 2. And it would give us the extra 2 on top. But not so focused on that there. But our last kind of notation is just rewriting y as f inverse of x is equal to plus or minus the square root of x over 2. So that there is our inverse function. Any questions on this here? Now we still need to find the input when the output is, I believe, 2, positive 2. So we're finding f inverse of 2, which is equal to plus or minus the square root of 2 over 2. What is 2 divided by 2? Square root of 1 is 1. So the value for this here would be plus or minus 1. Because if we think about the original problem, it is x squared, because 1 squared is still going to give us 1. Negative 1 squared is, well, it's just going to give us 1. So it is plus or minus 1. Questions on this here? So that tells us, if we think of the points from the inverses side, is that 2 comma 1 is a point on it, and 2 comma negative 1. Those 2 points are straight over the top of each other, yes? That would not pass the vertical line test as a function. So this inverse is technically not a function. This function technically did not have an inverse. But this is how we would solve it anyways. So we can still find the inverse, it's just not a function. Questions on this here? All right, let's look at the next one. F of x equals negative x cubed plus 3. What can we do first? Yeah, so y equals negative x cubed plus 3. And I think some of you have already switched it to x is equal to negative y cubed plus 3. I write that out just so we can see it, but again, you don't have to write that out. We could go straight from f of x equals negative x cubed plus 3 straight to x equals negative y cubed plus 3. Now we need to solve this for y. Well, the first thing we can do is subtract 3 from both sides. Which will tell us that x minus 3 is equal to the negative y cubed. What can we do next? So we need to get y by itself, yes? So we have a negative in the third power, yes? Which one do we want to deal with first? The negative. So we can do it in one of 2 ways. I can multiply both sides by negative 1. Or we could have divided both sides by negative 1. Either way, negative y cubed times negative 1 is y cubed. Is equal to, yes, exactly, we would cube root both sides. Cubed, yes. Since we have y to the third, we'll need the cubed root to simplify out that third power. Y cubed, the cubed root of y cubed is y. Okay. Is equal to the cubed root of negative x plus 3. Or we can say that f inverse of x is equal to the cubed root of negative x plus 3. And that would be our answer for finding the inverse. And this one here wants to know what the input is when the output is 2. Or again, we're just finding f inverse of 2 is equal to the cubed root of, well, negative 2 in parentheses plus 3. Well, that negative 2 in parentheses is just going to be negative 2, yes? What's negative 2 plus 3? What's the cubed root of 1? 1. Now, we don't need the plus or minus with cubed roots because any odd root, as we saw in this chapter, if what's inside is positive, we have one real root. If what's inside an odd root is 0, well, it's just one real root, 0. And if what's inside a cubed root is positive, well, we still have one real root. And that's all we have to do for this here. Any other questions on any of this here? Any other questions on inverses so far? Well, okay. Any other questions on how we find the cubed root? No, because this isn't any different than what we just did, or this, or that one. Questions on this one here? No, because I mean, these are the same thing. I'm definitely going to need to fix these note sheets. Well, we're going all the way here. Because again, even with those cubes, we did one with those. Because it's not any different. We're just going to end up taking the cubed root. Consider the function 2 times square root of x minus 3. Determine whether the inverse of f is a function. Then find its inverse. Now, we didn't luck out on this one here, or I think as y'all would consider luck out, in that if it's not a function, we don't have to find its inverse. Because it's just telling us determine whether the inverse is a function. Then find its inverse. So we're just determining if it is going to be a function or not. Now, again, we can look at this to see if it does pass the horizontal line test. And all we would need to do that is to graph it. Get this pulls up. So we can type it into the calculator. Both of those out. 2 times the square root of, I think it was x minus 3. X minus 3. And graph. Okay, that does pass the horizontal line test because it is going to continue to increase and it only crosses that line once. So its inverse will be a function. Now we just need to find it. So just like we did with the other ones, we can rewrite f of x as y. Y is equal to 2 times the square root of x minus 3.
I have a quick question.
Yes.
How do you get the y equals the y value? Just type it in. Oh, you just.
Yep.
That's so weird.
Yeah. A lot of stuff on the calculator, if you don't know what you're typing in, it can be very complicated. So, looking at this here, we'd switch x and y. X is equal to 2 square root of y minus 3. So we need to get y by itself to find the inverse. So what would we do first? We would divide by 2. Yes. And when we divide both sides by 2, these will simplify out. Now, what's the next thing we need to simplify or get rid of? The square root. And we can get rid of a square root by squaring both sides. And if we square both sides, well, here the square root and square would cancel, telling us that we got y minus 3. The other side, I have a single term, yes? And our quotient of a power of a quotient, says I can apply that power to both terms, top and bottom. So we can square the numerator x, and x squared is x squared. And the denominator 2 squared is 4. Because 2 times 2 would give us 4. Last but not least, what do we need to do? Add 3. And if we do this here, we'll get that y is equal to x squared over 4 plus 3. Or as we can denote it as f inverse of x is x squared over 4 plus 3. And that there would be our inverse. Questions on this here? So what I'm going to do is also graph our inverse function. And we get this here. So that doesn't look too remarkable. So the purple x. What do we know about the distance between the blue and red graph and that purple line? Well, they look to be about the same distance apart, yes? It works out that the inverse functions are a reflection across the line y equals x. And it actually works for any and all inverses. There'll be a reflection across this line. Now, if you notice, the blue line is only really half. It's only the ones in that positive x and positive y axis. Because if we look at the overall function, if we'd found the overall inverse of the red, its inverse wouldn't actually be a function. Because the bottom half would come down this way here and pass the vertical line test to be a function. Any questions on this here? Any other questions on anything we've covered so far today? We feel good with this here? It's way too hot. Up on there. We're going to go on and stop here for today. We will pick this up tomorrow, and again, I planned on this taking 2 days.